point in the class, you might think that this is going to be a somewhat complicated question, and it kind of is, but I wanted to show you how you sum the forces on an object when you have forces that are acting at angles, because that seems a little weird, right? And then I'm going to go by step what you should be doing when you come across some sort of problem. Okay, so I'm going to write those steps over here. So the first thing when you're solving a problem that involves forces, the first thing is to draw a picture. And the second step is to draw a free body diagram or a force diagram. Okay, so let's go ahead and do that. When I look at my box, it doesn't say that there's friction, and so I'm going to say maybe there is and maybe there isn't. So let's sort of see what we can figure out. All right, so the forces that are acting on this object, I'm going to get this sideways force, this force of tension. And instead of using on by notation, I'm just going to abbreviate my forces as just FT. I get a downward force. This is going to be my force of gravity. And then there's another force that I'm missing right now, and that's the normal force. That's going to be going upward. I don't have my vectors here. My arrows aren't really drawn to scale, and that's okay. I'm just sort of piecing this out. Now here it says the box does not move. And so when I look at my force diagram, when I look at my free body diagram, if the box does not move, then the left forces need to be equal to the right forces, and the up forces need to be equal to the down forces. So as I'm looking at this, this is not balanced. And so I need to add a backwards force onto my force diagram. Now that force that's preventing the box from moving, that's going to be the force of friction. Okay, now the second thing, draw a free body diagram. Step 3 then is going to be sum the forces in the X and Y directions. So I'm going to look at the sum of the forces in the X direction first. Now, because the box does not move, I know that I am in equilibrium. And what does that mean about the sum of the forces in the X direction? Well, that means the sum of the forces in the X direction is going to be equal to 0. Now, when I look at this diagram, I only have one force that is completely in the X direction, and that's the force of friction. So I need to double check my free body diagram. I do have the X part of this force that is going in the X direction. And then the Y part of it, there's another part that goes in the Y direction. So I'm going to label this side of the triangle FTX. Okay, so the sum of the forces in the X direction is going to be equal to 0, and that is this shadow, this leg of the triangle, the force of tension in the X direction, minus the force of friction, which is the force that's in the negative direction. So the force of friction is going to be equal to the force of tension in the X direction. And so this is just asking, what is the force of friction? And so we're almost there. Now, I just need to figure out what this is, or how big this component, this leg of my triangle is. So here is my angle theta. And we know from the problem that theta is 25 degrees. So when I look at this, this horizontal component, the X component of this, is my adjacent side. It's right next door to this angle. And it's every single one of my papers ends up with this on it. Just because I have trouble remembering. And so I'm looking at adjacent side. That adjacent means cosine. So I take the cosine of my angle, and that's going to be equal to the adjacent FTX over the hypotenuse That's my overall force of tension. So that gives me the force of tension times the cosine of theta is the force of tension in the x direction. So the force of friction is just the force of tension times the cosine of theta, or 15 newtons times the cosine of 25 degrees. Now, it doesn't matter if you're using degrees or radians. Most of the time when problems are given, we'll give it in degrees because we have a better idea of what degrees are. But any other time you come up with angle measures in physics, if it's most of the time we use radians, but in this case we'll use degrees. And then we just plug that into our calculator. Now, what happens if the question asks, what is the magnitude of the normal force? So if this problem is asking what is the magnitude of the normal force, well, the normal force, we're going to have to sum the forces in the y direction. So we did step 3, and to answer one of the problems, we only had to sum the forces in the x direction, but now we have to sum them in the y. All right, so the sum of the forces in the y direction, it's not accelerating up or down, it's moving at a constant speed, or that speed is 0, so it's not moving. So the sum of the forces in the y direction is going to be equal to 0. So we take all of our upward forces. We get the normal force is going upward, and then we get this part of the force of tension that is in the upward direction, or the force of tension in the y. So the normal force plus the force of tension in the y direction minus the force of gravity is going to be equal to 0. Now, at this point, I'm going to do some manipulation. I'm going to move this to the other side. So I get negative the normal force equals force of tension in the y direction minus the force of gravity. Then I'm going to multiply by -1 just so that this is positive. Okay. Now, force of gravity. The force of gravity is just the mass of the object times the gravitational field strength. Remember, the gravitational field strength, G, is 10 meters per second squared. All right, so the normal force is, now we need to figure out the force of tension in the y direction. The force of tension in the y direction. Okay, so that is the opposite side, because this angle looks across to it. That's the opposite side of my triangle. Opposite is the sine. So I'm going to take the sine of theta is my opposite, the force of tension in the y direction, over my hypotenuse. Remember, that's my hypotenuse is the force of tension. So the force of tension in the y direction, if I multiply this across, is just going to be Ft sine theta. So this is going to be negative, the negative comes down, Ft sine theta. Now we can go ahead and plug some numbers in. I'm going to move this to the front. So it says here that it's a 4 kilogram box, and so I'm going to say 4 kilograms times 10 meters per second squared minus my force of tension, which was 15 newtons, times the sine of theta, which is 25 degrees. And that will give me my normal force. Notice how when you're pulling up on this, this is going to be less. So this is the force of gravity, or it's going to be the force of gravity is going to be 40 newtons. And you're subtracting off some piece. And so the normal force, if I'm pulling up on an object, the normal force is actually going to decrease. If I push down on an object, the normal force will increase. Think about standing on a bathroom scale and having your friend like pick you up versus push down on you. If your friend is pushing down on you, that scale, which actually reads your normal force, that scale which reads your normal force will be bigger if somebody is pushing down on you. But if they're pulling up on you, just a little bit even, if they're pulling up on you, you're going to weigh less. The scale, which reads your normal force, will give you a lower weight. So if you're pulling up, the normal force will decrease. And if you're pushing down, the normal force will increase. I trust that you have calculators there that you can plug these numbers in and get an answer.